Today's video will help you review the procedures for writing net ionic equations, calculating concentrations, and the rules for significant digits. When writing net ionic equations, the very first step is to write the balanced equation. Once that is finished, use the solubility table in your data booklet to determine which of the ionic entities will dissociate. Rewrite the equation with all soluble ionic compounds separated into their ions and the acids ionized. Any entities that are the same on both sides of the equation should be canceled out. Your final step would be to rewrite the equation to show the net ionic equation. Here is an example with the reaction of barium chloride and sodium sulfate. In step 1, the double replacement reaction is predicted and the equation is balanced. For step 2, a quick check of the solubility table showed me that barium sulfate is the only entity that won't dissociate. In step 3, I canceled out chloride and sodium ions because they were on the reactant and product sides. In step 4, I wrote the final net ionic equation. The next topic we will be reviewing is concentration. We can use the mass and molar mass to calculate the number of moles, and we can use the number of moles and volume to calculate the concentration. We will go over several examples with these calculations during class. The next concept that we will be reviewing has to do with determining the concentration of ions in solution. A solution's concentration is not necessarily the same as the concentration of its ions. To find the concentrations, you will need a balanced equation because you will need to use the coefficients to calculate the individual concentrations. In this example, we have an aluminum sulfate solution that has a concentration of 0.40 moles per liter. The first step in calculating the concentration of the ions is writing the balanced dissociation equation. From there, we need to use mole ratios of the coefficients to calculate the concentrations of the ions. For aluminum ions, we take the known concentration of the solution and multiply it by 2/1. The 2 is the coefficient in front of the entity we are solving for, and the 1 is the coefficient in front of the entity that we already know. We will always use unknown over known. To calculate the concentration of sulfate ions, we will use the ratio of 3/1. Significant digits are an important concept because you will need to remember them for nearly all of your work in Chemistry 30. Can you remember the significant digit rules from Chemistry 20? Each example here has 3 significant digits. Let's review the rules to see why. Here is a summary of the significant digit rules. Leading zeros are not significant, but trailing zeros always are. When we have logarithmic values such as pH, any digit to the left of the decimal is not significant. Oftentimes, the number of significant digits will be affected by the operations being performed. If we add or subtract, then we will want to round our answer so it has the same degree of precision as our least precise number. If we are multiplying or dividing, our answer will be rounded to the same number of significant digits as the number with the fewest significant digits. Do not round your answers off until the final step. This will help you keep your work as precise as possible. In the first example here, the numbers are all being added. The least precise number is rounded to the tenths place, so the answer is also rounded to the tenths place. In the second example here, we will use the rules for multiplication. The number with the least significant digits has 3. This means that the final answer will also have 3 significant digits. Thanks for completing your homework. When you get to class, we will be reviewing these concepts and going over a few examples.